Hi students, good morning. I think all of you are keeping well. Welcome to our physics classes, new session of our physics classes. In the last class, I introduced the new syllabus to you, and I think all of you have got your textbook now, and you have two parts, two textbook you have got, two parts you have got, and in first textbook you can find 6 units are there. In the first textbook, 6 units are there, and these units are physical world and measurement, kinematics, laws of motion, work energy and power, then rigid body rotation, then gravitation. These are the 6 units in your first part of your textbook. And from that 6 lessons or 6 units, the first unit is physical world and measurement. That unit is already you have learned from your lower classes. Physical world, what you mean by physics, what is the meaning of physics with the different branches of physics. All those matters you can read in the first chapter, physical world. And second chapter is units and measurement. Units and measurement you have learned from your, I think from the 6th classes, you have learned about different units. What is the need of measurement? What is the method of measuring different physical quantities? And which are the different units used for? All those matters you have already learned. And new content or error analysis also I think you have already learned from your lower classes. So you have to just refresh all those matters here. And it's a very fundamental concepts in physics. Then one new concept is introducing there is that is dimensional analysis. If you have a physical quantity and you have to express it as a unit, and how you can express it in terms of its dimensions. So dimensional analysis is a new topic for you, so that we have to discuss. But for the time being, I'm keeping that first unit aside, which means from almost 80% or 90%, almost 90% of first unit you have already learned from your lower classes, and we will use those concepts. Meanwhile, we are discussing all other chapters now. So when we complete first or second or third units, then after we will come back to that first unit. Okay. So while discussing the concepts in the second and third unit, when we are advancing, we are making use the concepts given in the first unit, which is already learned. And meanwhile, we will talk about the dimensional analysis also, or how you can derive the quantities of dimensional formula or dimensional analysis, how you can make the dimensional analysis of different physical quantities that we will come across when we are going ahead. So after that, when we discuss about the first unit, it will be more easy for you, since almost 90% you have already covered, and that rest 10% we will discuss along with the other concepts. So after completing 2 or 3 units, we will come back to the first unit. That will be very easy for you. Then it will be easily grasped. Okay, so don't get tensed, don't get worried. We will discuss that first unit after completing second or third unit. Okay, and here I think we have to start with the second unit, and the second unit is kinematics. Second unit is kinematics. The concepts in kinematics that you have already came across during the earlier syllabus, which means in 7, 8, 9, 10 syllabus, you have already learned about the basic concepts in kinematics. And here we are refreshing those topics, and we are extending our level of conception into a deeper level or a wider level. That we are doing in the first, fourth chapter in your textbook, that is the second unit, fourth chapter, that is motion in a straight line. So now we are starting with our fourth chapter, that is the second unit, fourth chapter, motion in a straight line. Okay, you have already learned how you can say an object is in its state of rest or state of motion. How you can say object is, suppose, let me ask a question. In which state you are now? State of rest or state of motion? Some of you, I can imagine some of you are saying that you are in the state of rest since you are sitting in the chair and watching this video. So you are in the state of rest. And some others are saying that I am in motion because I am using my headphone and I am taking my phone in my hand and I am walking. So I am in state of motion. And some of you can say, even though you are sitting in the chair and watching this video, you can say, or you may say, you are in the state of motion. And I suppose almost all of you have to, not almost, all of you have to say that you are in state of motion as well as in state of rest. Can you agree with me? All of you are in the state of rest. Simultaneously, you are in the state of motion. You are thinking that this teacher is a mad. How a person can be simultaneously at rest or simultaneously at motion? That is the beauty of physics. That is the beauty of physics. The same system you can say in a state of rest or state of motion when you are referring to different points. When you are referring to different points. So I can make it simplified. How you can differentiate the state of rest and state of motion? To describe or to define the state of rest or state of motion, you have to refer the position of that particular system with respect to a particular point. And what you call that particular point? That particular point is called point of reference. That is called a point of reference, or simply the reference point. Suppose you are sitting in your room and a table is there, and in front of the table a chair is there, and you are keeping this mobile or laptop, whatever may be, on the table, and you are sitting in the chair and watching this video. And you feel that you are in the state of rest. Why? Because your surroundings are not changing, or you are not changing your position with respect to your surroundings. So you can say you are in the state of rest. Is it? Suppose a person is carrying the mobile in their hand and watching the video while walking. So he is moving from one room to another. So as the time goes, his surroundings are changing. So he is in the state of motion. Is it? So we can differentiate the state of rest or state of motion with respect to a reference point. I can define state of rest if a system does not change its position with respect to a reference point, then that system is in the state of rest. If a system changes its position with respect to a reference point continuously, then that is in the state of motion. Then that is in the state of motion. So to define the state of rest and state of motion, you require a fixed point, and that fixed point is known as reference point. And where you are keeping that reference point, that space is known as frame of reference. To differentiate the state of rest and state of motion, you need a reference point, and where you are keeping the reference point, that space is known as frame of reference. Simple words. Physically, you can define the frame of reference as the frame coordinate system, the coordinate system in which Newton's first law holds good. The space where you can apply the Newton's first law properly without any change, that space is known as frame of reference. That space is known as frame of reference. Okay, you know what is Newton's first law. We will come to that later. But anyhow, the frame, the coordinate system in which the first law holds good is known as frame of reference. Frame of reference you can keep anywhere. Suppose you are traveling in a bus. You are traveling in a bus and you keep the driver as the frame of reference or reference point. You keep the driver of the bus is as the, or driver of the car, whatever maybe, driver of the vehicle, you make it a reference point. And where that person is sitting inside the bus, and you are also sitting inside the bus. So the frame of reference is that bus itself. Okay, so you have the frame of reference as the bus and driver as the reference point, and the driver is driving the bus and the bus is moving and you are sitting in a seat. With respect to the reference point, is there any change into your position? Not at all. So you are in state of motion. Sorry, you are in the state of rest. You are in the state of rest. Can you agree with me? With respect to the driver, you are sitting in the same seat even though the bus is running, but you are in state of rest with respect to the driver, because with respect to the driver your position is not changing. So your frame of reference is the bus itself and the reference point is the driver, so you are in the state of rest. Are you in the state of rest then? Is the bus is running? If the bus is running, are you in the state of rest? Not at all. So you are in the state of motion with respect to the person standing outside the bus. Anybody who is standing inside the bus finds you at every time at the same seat. So with respect to him, you are in the state of rest. But anybody is standing outside and watching you, bus is running, you are inside the bus. Since bus is moving, you are also in the state of motion. So at the same time, you are in the state of rest to a person inside the bus, and you are in the state of motion to a person just outside the bus. What makes the difference? The difference is where you are keeping the frame of reference, or where you are keeping the reference point. So a system can be state of rest or motion with respect to different frame of references. So the reference point and the frame of reference determines the state of a system. Can you understand me? The state of a system is determined by the reference point and the frame of reference where you are choosing. Is it? With the same example I explained, a person inside the bus, running bus, is seen to be stationary to a person sitting in the same bus, but the same person is seen to be in motion when a person outside is watching that. Okay, so the frame of reference and and the reference frame determines the state of motion or state of rest. So simply you can say the state of a system is determined by the frame of reference and the reference point. Okay, in that way we can differentiate the state of rest and state of motion. If the position changes continuously with respect to a reference point, then the system is in its state of motion, and there is no change at all for the position with respect to the reference point, then it is in the state of rest. So you have already learned all these matters, and you came across with or you are familiar with some terms related to the state of rest or state of motion. So we can see what are those points. Okay, we can see now the different important terms related to motion. See, the first one we have already defined, the frame of reference, and the frame of reference can be of two types. One is inertial frame and the other is non-inertial frame. Inertial frame and non-inertial frame. I already told you the frame of reference in which the Newton's first law holds good. That is known as inertial frame of reference. That is known as the inertial frame of reference. In inertial frame of reference, it is a non-accelerated and non-rotating frame of reference, because first law says about uniform motion. Uniform motion, you know, with a constant velocity. So when it is a constant velocity, that is non-accelerated. So a frame of reference which is non-accelerated one is known as inertial frame. So obviously an accelerated frame of reference is non-inertial frame. Okay, so inertial frame can be of two types. Frame of reference can be of two types: inertial frame of reference and non-inertial frame of reference. So in inertial frame of reference, first law holds good, Newton's first law holds good, it is a non-accelerated frame. And the non-inertial is an accelerated frame of reference. Then another one is a point mass. An object, it is traveling a distance. Suppose an object is traveling. So suppose an ant is traveling 10 kilometers. An ant is traveling 10 kilometers. So can you imagine the size of an ant? And can you compare the size of that ant with the distance traveled by that? The distance traveled is 10 kilometers, and the size of the ant will be maximum 1 or 2, maximum half or 1 centimeter. So comparing to the size, it traveled a large distance, very large distance. Such an object is called point object or point mass. Okay, a point object is an object whose size is very, very negligible compared to the distance traveled by that object. It is called a point mass. Okay, so the second term is point mass. Then state of motion. We have already defined how you can define the state of motion. Then state of rest. What is distance? The total path length traveled by an object. That is distance. What is displacement? Displacement is the straight distance between initial point and the final point. Straight distance between the initial point and the final point. What is speed? Distance traveled per unit time. What is velocity? Displacement per unit time. What is acceleration? Velocity change in unit time. All these terms you have already well learned from your lower classes. So from these you can see the distance, speed, both are scalar quantities. Displacement, velocity, acceleration are vector quantities. What is a scalar quantity? A quantity which has only Magnitude is known as scalar quantity. The quantities which are having magnitude as well as direction is known as vector quantities. And what are the other quantities of, other scalar quantities? Mass is a scalar quantity, time is a scalar quantity, then current is a scalar quantity, charge is a scalar quantity, and force is a vector quantity, pressure is a scalar quantity or vector quantity. That up to you. Okay, so we can have different terms that can be classified as scalar quantities and vector quantities. So all these matters you have already learned. And what is the unit of distance? Meter. What is the unit of displacement? That is also meter. And what is the relation between distance and displacement? Distance is the total path length covered between 2 points. What is displacement? The straight distance between those 2 points. So displacement is always less than distance. Displacement is always less than or equal to distance. That you can imagine how it will be. Distance is always greater or equal to displacement, or displacement is always lesser or equal to distance. And speed is distance traveled per unit time, velocity is displacement traveled per unit time. Both are measured in meter per second. And acceleration is change in velocity per time, that is its unit is meter per second square. So all these you have already well learned, so refresh all those matters. Okay, now suppose you are observing an object. And that object is changing its position continuously with respect to time. So you can call that object is in its state of motion. Since it is changing its position with respect to a reference point continuously with the time, so you can say that is in the state of motion. That object is in the state of motion. So you are observing that object continuously. And you are recording its position with respect to time. As the time goes, you are measuring its position and you are recording its position with respect to time. And when you are plotting that time and position along a graph, taking time along x-axis and position along, or the distance or displacement along y-axis, you are getting its time displacement graph. So our next topic is time displacement graph for different situations of a system. So let us see what is the time displacement graph for different situations of a particular system. You see the graph here. Time is taken along x-axis and the displacement is taken along y-axis. And at time 0, the position is also at 0. Then after 1 second, it covers 20 meter. And by 2 seconds, it covers 40 meter. And by 3 seconds, it covers 60 meter and so on. Which means it covers equal distance in equal interval of time. So this kind of motion is called uniform motion. So you define uniform motion as if a particle covers, or if an object covers equal distance in equal interval of time, then that is called uniform motion. So this diagram or the graph shows time displacement graph for a uniform motion. And I think you have already learned how to make the slope of a graph. How to make the slope of a graph. How you can make the slope of a graph? Slope of any graph is change in its y coordinate divided by change in its x coordinate. Change in y coordinate divided by change in x coordinate is slope of a graph. So what is taken along the x axis here? Time. What is taken along the y axis here? Displacement. So the change in y coordinate will be S2 minus S1, that is delta S. It is denoted there. S2 minus S1, that is final position minus initial position, that is delta S. And corresponding x coordinate changes will be T2 minus T1, that is delta T. So when you are calculating a slope, slope will be delta S by delta T. Slope will be delta S by delta T. What is delta S by delta T? Change in displacement divided by change in time. Change in displacement divided by change in time. What is that? By the definition, that is velocity. By the definition, that is velocity. So the slope of time displacement graph gives velocity of that particular object. Slope of time displacement graph gives the velocity of that particular object. So that is the importance of time displacement graph. One of the importance of time displacement graph. Slope of time displacement graph gives, please note down, slope of the time displacement graph gives the velocity of that object. So the velocity time graph, displacement time graph refers to its velocity. How? The velocity is the slope of that time displacement graph. So if you have the time displacement graph for two objects, you have the time displacement graph for two objects, and you are calculating you have to refer which one is moving faster than the other. Which one is moving faster than the other? How you can find out? If you know the velocity, you can easily say which one is moving faster than the other. So how you can refer to the velocity if you find the slope? But slope, without calculating slope from the by seeing the graph itself, you can refer or we can infer which is faster or which is slower. See, I will show you now. See, here you have time displacement graph for two objects, object A and object B. Which is faster? Which is faster? See, from the graph, slope of A is more than slope of B. Is it? Slope of A is more than slope of B. That means its slant is more. I mean, that is slope. I mean, how, which angle it makes with the x-axis or x-axis, time axis. That is actually slope. So slope of A is more than slope of B. What is slope of displacement time graph? That is velocity. So if the slope is more, velocity will be more, which will be faster. So slope of A is more than B, which means velocity of A should be more than velocity of B, which means A is faster than B. So if the slope of the time displacement line is greater, its velocity also will be greater. Okay, that is another inference from the time displacement graph. If the slope is more, the velocity also will be more. Okay, now I will show you another graph. See, one more graph is there. You have the time along the x-axis and displacement along y-axis. At 1 second, it is at the 30 meter from the origin, and at 2 second it is again at the 30 meter from the origin. 3 second, 4 second, 5 second, and goes on. That position remains at the 30 meter from the origin. What it says? It says that object is not changing its position with respect to time. So that is a object under state of rest. Okay, so the position time graph, the displacement time graph of a resting object is a line parallel to time axis. A line parallel to the time axis. Not x-axis. If you are taking x-axis, I mean time along y-axis, it will be parallel to y-axis. So we can't always say that it is along x-axis, but you can say that it is parallel to the time axis. It is parallel to the time axis. Okay. One more graph is there. See, another graph is there. You see that graph properly. See, initially that object is at a distance 20 meter from the origin. As the time goes, it comes back to the origin. It comes back to origin, and it moves in the opposite direction. And it moves in the opposite direction. So what will be the slope of that object? See, the angle measured. Angle measured is more than 90 degree. The angle measured is more than 90 degree. So if the angle is more than 90 degree, it means that the object is returning back towards the reference point. If the position time graph, the displacement time graph is also known as position time graph. Okay, so if the position time graph is making an angle more than 90 degree with the x-axis, that is the time axis, then the object is returning back to its reference point. Okay, so first of all we have seen the velocity, sorry, first of all we have seen the displacement time graph for the uniform motion. Then we have seen if the slope is more, the velocity is also more. Then for a resting object is parallel to the time axis. Then if the object is returning back to its initial point, then its slope is more than, or the angle made by the position time graph with the time axis will be more than 90 degree. Okay, so these are the inferences taken from position time graph. Remember, the slope of position time graph is the velocity. Slope of position time graph is the velocity. Okay, now you see another diagram. Which is also a position time graph. Position is taken along y-axis and time is taken along x-axis. And it has different lines. OA is there initially, and AB is there, BC is there, and CD is there. And what about the slope of OA, AB, BC, and CD? All are same? No. The slope of each line is different. Since slope refers to the velocity of that object, we can say that from O to A it travels with a velocity, and from A to B it travels with another velocity, and B to C it is traveling with another velocity, and from C to D it travels with another velocity. Which means if the position time graph has several lines of different slopes, then it travels with non-uniform velocity. Non-uniform velocity means the velocity is not constant throughout. It travels with the different velocities. Okay, that is another type of position time graph. So if the position time graph is having different lines with different slopes, it is moving with the different velocities. Suppose it happens in another way. I will show you. See, here you can find the position time graph as a curve, continuous curve. Which means if the time displacement graph is a continuous curve, then its velocity continuously changing with respect to time. So here you can define the average velocity of that object. You can define the average velocity of that object. See, you can have different two times t1 and t1 and t2 with the displacement change s2 and s1. So s2 minus s1 divided by t2 minus t1, that is delta s by delta t, change in y coordinate divided by change in x coordinate. That defines the average velocity. That defines the average velocity. Okay, so average velocity and average of velocities are different. In the first curve, you can find different lines with different velocities. So from O to A travels with a velocity, from A to B it travels another velocity, B to C another velocity, C to D another velocity. So you can find out the average of all those velocities. And here it's a continuous curve, and there you can find the average velocity of that object. So average velocity and average of velocities, two different terms are there. Okay, so these are the time position graph or time displacement graph of different situations. Time displacement graph of different situations. Here we have seen six different graphs. We have seen six different graphs, and these six different graphs shows the six different situations, and we can infer six different concepts from these six graphs, six different graphs. Okay, so that is the displacement time graph. And the displacement time graph, the slope of the displacement time graph is gives the velocity, and we have defined uniform velocity, uniform motion. Uniform motion means movement with the uniform velocity. Uniform velocity means the velocity does not change with respect to time. That means always the velocity remains the same. That means equal distance is covered by equal interval of time. So that is uniform velocity. And non-uniform motion, average of velocities and average velocity. So that is time displacement graph. Okay, so that's all for today, and you just go through the topics that we have discussed. And next topic that we are going to discuss is the velocity time graph and the equations of motion. Equations of motion also you have already learned from the graph how you are deriving that equations of motion that you have already learned. You just go through that, you just refresh that, and we have to define the same equations of motion using another method. That method is a new method to you. So before deriving using that method, we have to define that, before deriving that equations of motion, you have to learn that new method, that is the method of calculus. So that we will discuss in the next coming classes. So I think maths students, you are getting an extra advantage that, see, physics has its own language, and physics has its own tools also. One of the important tool of physics is mathematics. One of the important tool of physics is mathematics. So you can read that most of the maths concepts are discovered or introduced by physicists. And mathematics steps or mathematical methods are only the tools for solving the difficult problems in physics. So maths students, they are getting an extra advantage that they will learn that maths steps and methods in their maths classes also. But bios, they are practicing that very much. So they will be thorough with their steps. But bio students, you are not getting that a chance. But we will discuss all those matters, those topics which are related to physics, the tools that we required in physics derivations, that we will explain before we are using that. Don't get tensed, but that much practice you will not get because you are not learning mathematics. So you have to take an extra effort for practicing those mathematical methods. We will explain in the class, we will practice also, but to grasp that in the full fledged, you have to make some more practice. So that practice you will not get in the classes, but that you have to make by yourself. But maths students, they will do that practice during their maths classes. So they are getting an extra advantage over there. But it is not a problem for bio students. Whatever required for physics classes, that I will discuss in the class. Don't get worried. Okay, so anyhow, learn it properly, and already I told you how to learn physics. Learning physics is an art. Learning physics is an art. And how you can understand physics? You can understand physics by closing the textbook and open your ears and eyes to the surroundings. How you can understand physics? Close your textbook, open your ears and eyes to the surroundings. How you can learn physics? Close your ears, open your eyes and textbook and the classes. Okay? While you are understanding, you open your ears and eyes to the surroundings. Because from the surroundings you can understand the physical concepts, physical theories, physical laws. Everything that we have discussing in physics you can find in the universe or the surroundings around you. That I told you, to understand physics, you open your eyes and ears to the surroundings. But when you are learning physics, you just close your ears to the surroundings, because nobody can disturb you at that time. And you open your eyes and your textbook, because at that time when you are reading or listening to the class, don't listen to the surroundings. Full concentration you have to pay here in the class and while you are reading from the textbook. Okay, and during the class you can make some notes, and with the help of physics textbook you can make your own notes, and all the derivations and all I will show you in the slides. You can get all those derivations and steps and all through my slides, and that you can make use for preparing the notes. And two copies you have to keep with you, one for the notes and the other for solving numericals you have to solve in a separate book. Okay, so two notebooks, two copies you have to keep along with you, one for preparing the notes and the other for solving the numericals. Okay, so read this content well, and prepare the notes according to the class and referring to the textbook. Okay, so we will meet in the next class, and all of you keep well. Bye.